Hello everyone, mic test. Okay, I can hear myself. Very good. Right, let's begin. Alright, welcome to today's Facebook Live session, happening every Wednesday, brought to you by Maths Heuristics. So for those of you who just joined us, if you don't have the notes already, you can come hit to this URL over here, mathsheuristics.com/blog, to download the notes to print out. And secondly, if you would like to view our archives, you can also view it over here. Okay? For 2019, we've been updating them regularly, so you will be able to see them. Okay? So a bit about myself. I'm the curriculum specialist here at Maths Heuristics. I've been working here since 2011, and I hope that there's many more years to come for me to be in this company. Okay, for me, the thing I like about this company is that it gives me autonomy to explore things that I'm interested in doing, such as looking at technology, how to use technology to augment students' learning, how to use technology to improve our productivity, and number 3 is to explore deeper into mathematics, which is something I've always liked to do. Okay, they've been giving me chances to teach Maths Olympiad. It gives me a very strong motivation to continue learning at the deeper levels. So I'd like to shout out to my boss here, Mr. Sani Tan, who has groomed me over the years. I'd like to thank him for all the chances that I've been given and this privilege that I have to share with all of you about patterns tonight. So let me just talk a bit about the Mastering Heuristics series. This is a set of books that my boss and mentor has written over the last several years. The first book, The Unit Transfer Method, came out back in 2008. That was the first edition. And over the course of the next few years, we published several other books focusing on certain techniques. Okay? So today I'll be talking about patterns. We do not have a publication for this yet. But let me just briefly explain some of the thought processes in breaking down pattern questions. I believe the thought process is the one thing that many students lack in dealing with problems, and most of the time they like to memorize. They just choose to memorize something which they do not understand. It's not a bad thing, because sometimes that is the best that they can do. Okay? And you can't really blame them for it. Children do the best that they can, and I think they should be commended for that effort. Alright? So let's talk about patterns today. So the first one will be on common difference. Okay? Hang on, let me just shout out to everyone. Okay? Hello to Suvita Kumar, Susan, Sing Ming Leong, Rose, Agnes, Kendrick, Wendy, Rekha, Janavi, Jessica, Jonas, Adeline, Frisch, Rai, Ang Wei, Veron, Janice, Tirana, Unicorn, Jermaine, Kelly, and many more. Okay, thanks for being here. Alright, let's go. Hello, Tongan, Aaron, Mei Ling, Ethan. Okay, right, let's begin on the first example of 4. Right, David used some... okay. David used some coins to form a series of L-shaped patterns. So you can see that the first pattern looks like this. It has 3 dots over here. The second pattern looks like this. Then the third pattern looks like this. So we are to complete the table below. Okay, what is a pattern in the first place? A pattern is a set of rules that... Okay, a pattern is that all these figures will follow a specific change, and that rule applies throughout. Okay? So in a pattern, the first and foremost thing you want to do is to look for the changes first. How does it change from pattern to pattern? So let's look at the first one. The first one, we see that we have 3 dots over here. Later on, I added on another 2 more dots over here. I would have 5. And later on, I added on another 2 more here. I would have 7. So all these figures can be translated into numbers. And the reason why examiners set figure patterns is to give students who are more visually inclined a fair chance at solving this, because some of them, they tend to interpret the figures better and can reason out how it changes and why it changes that way. Okay, so you can see that over here, every pattern that I have, every subsequent pattern that I have, every subsequent figure that I have, I'll be adding 2 more, and I'll be adding 2 more, and I'll be adding 2 more. So this rule should, if this rule were to continue all the way through, the 4th one should have 9. The 5th one should have 11, and the 6th one would have 13. Because it follows a rule of adding 2 each time. Agree? So now the next question is, write down the number of coins that David would need to form the 100th pattern. Okay, so there is this thing that my student did before. Okay, she literally listed out that was for like the sum of consecutive numbers. She literally listed out the first 100 numbers and go and sum them up manually. Okay, please don't go and do that. Okay, as your first line of action, please don't do that. Okay, to deal with this, we want to look at how it changes and try to use the pattern number to predict its behavior, its outcome. So here we can say that in the first figure we have 3. Over here in the second position, the second pattern, we have 3 plus 2. Over here we have 3 plus 2 plus 2. Over here we have 3 plus 2 plus 2 plus 2. We can rewrite them in this manner, and you will see that over here we can say that this is 3 plus 1 copy of 2. This is 3 plus 2 copies of 2, and this will be 3 plus 3 copies of 2. Agree? Okay, please don't go and do that. So when we have excuse me, when we have the 100th L-shaped pattern here, it should also follow this rule whereby the number of coins will be 3 plus something times 2. So the question now is, what is this something? Okay, to deal with this, let's look at how all these number of 2's are related to your pattern number. it is always one less than your pattern number. Correct? So based on this, if this were to be the 100th term, then this, I'll be adding on 99 copies of 2. So this 100th pattern will be 3 plus 99 times 2. Okay, so here be careful if you're pressing the calculator to compute this directly. Make sure you press it in this specific order, all in one shot. What one of my students did last time was, he go and press 3 plus 99, he press equal to this, then he go and times 2. Don't go and do this. Don't go and do this. Follow the order of operations strictly. So here you would have 99 times 2 plus 3 to give you 201. So this is your answer for part B. Okay, very good. Yeah, Wendy. Yeah, unicorn, don't go and do that. Follow the rules of your operations. Okay, Jing Wei Chong got it. Aaron. Rekha, you got it. Yeah, Tongan, you got it. Nixis got it. Okay, so over here, now next one is the reverse. Now I tell you that this pattern is formed, a particular pattern is formed with 601 coins. Which pattern would it be? So over here, if I were to have, okay, let me use green. Okay, now I tell you that your number of coins is 601. I want to find out what number this is. What is this pattern? So if we are to look at this relation closely, this 601 is formed by 3 plus something times 2. Okay, so if we are to visualize this with a part whole model, you have a 3 and several copies of 2's that has been added on. This is your first 2. You don't know how many 2's that you added on, but you do know that this entire sum will be 601. So once you have that model represented, it becomes quite easy to find the number of 2's that was added on. So then this will be 601 minus 3. To give you 598. Then we take 598 and we divide this by 2 to find out how many 2's was added on. And this will give you 299. But is this your final answer? A lot of you are very much aware of the whole situation around you. A lot of you are writing to 300, which is very good, because you have to recall that this 299, or rather the number of 2's added on, is always one less than your figure number. So this would have to be 299 plus 1 to give you 300. So this would be your answer for part C. Okay, very good. Yeah. Very good, all of you. Yeah, I'm watching myself. I need to see what is on the screen, what is being displayed to you all, so I can adjust. Okay? So if you got it, please spam the like button. Yeah, correct, Janice. Very good, Janice Steele. Yeah, you can also define it that way. Okay, in the next example, I'll also show you another way that this can be defined. But when in doubt, just fall back on this fundamental reasoning. Okay, very good. Okay, let's go on to number 2. So over here, you see that each pattern in the sequence is made up of square tiles. So pattern number 1 has got 3 square tiles. In pattern number 2, what changed? these two blocks was added on, and for pattern 3, these two blocks were added on. Correct? So here's how you can reason out from the figure itself. You can say that, you can notice that inside the first, second and third, this dead weight is always fixed over here. Okay? And you would always be adding 2 to the figure. So here is another way that we can define this. We can say that there will always be a fixed term, 1. And it will always be, you will always be adding 2 copies of the pattern number. Correct? The number of pairs that you are adding on corresponds with this pattern number here. So using this figure itself, this is arranged in a very nice manner. You can define it in this manner. Your pattern number multiplied by 2. 1 plus the pattern number multiplied by 2. So if we are to go up to pattern 25, then we can say that using this formula, using this relation, this must simply be 1 plus 25 times 2. So this would give you 51, which is your answer for part A. Okay, it's quite similar to the previous question in that you start out with 3 and you keep on adding 2. But the one point I want to highlight here is that using the figure itself, it looks easier to reason out. And also the objective of this is to show you another way that this can be defined. So some students, they always panic when I show them one way, and then they'll be like, can you do it this way or not? The answer is yes. As long as it's mathematically correct, it's yes. It's a yes. Okay? So using this idea, using this definition, we can also answer part B like this. In which pattern would your 399 square tiles be used? So here, this is 1 plus something times 2 to give you 399. And if we are to follow that part-whole model definition, your entire bar is 399. It is formed by 1 and several copies of 2. Okay? So over here, this will be 399. To find out the number of 2s, you want to subtract off 1 first to get 398. And we take 398 and we divide this by 2. Then this would give us 199. So using this definition, do you have to add back 1 to it? Yes or no? The answer is no. You don't have to add it back because this 199 is already that pattern number itself. And hence, this would be your answer. Okay, so what is the difference between guided example 1 and guided example 2? Guided example 2 over here, we are defining it in terms of your pattern number. So a few of you are asking, why must you take 50 plus 1? Or why must you take 1 plus Pn times 2? The reason is the pattern number corresponds with the number of pairs that you have. Correct? And this fixed term, or what I like to call dead weight, this dead weight over here is always fixed for every one of them. Okay? Very good. Excuse me. Okay, good. Why need to minus 1? Here, okay, you look at the part hole model, you have a lot of copies of 2. This 1 is the dead weight that's interfering with your reading. You want to get rid of it first. Okay? Right, so thank you for that. Let's move on. Oh crap. Hang on. Can you all see this clearly? Okay, let me just change this back to white mode first. Okay, okay, then here are all the boundaries. Adeline, try to refresh your browser first. Okay, so over here, number 3, numbers are arranged in the table below. What is the number in box X and Y inside this table? Okay, this kind of repeated grouping question tends to come out a lot. So there's generally a few ways to go about doing it. Let me just show you a few ways on how to interpret this problem. So first things first, if we go back to the main rule of thumb, which is to look for how it changes. We can see that this sequence follows a particular order. It goes from 1, 2, 3, 4, 5, 6, 7, 8. Then it goes to 9, 10, 11, 12, 13, and then they cut off the pattern. So the way it goes is that it follows this order of movement. So if this was if this would be 13, then this would be 14, this should be 15, and this should be 16. Okay. So now if you go down to row 12, you have to find out the number and the number x over here. What is one number that we can use to deal with this problem here? Okay, it's no longer the same as the example 1 and 2 already. This is a different kind of structure, but it still revolves around common difference. Okay, you see that the way it works is that the first way of dealing with this problem is you can see that your multiples of 8 will always be on the even row over here. Correct? So, based on this idea, you want to look at odd or even pattern numbers. So when this is even, you can see that this would simply be whatever this number is multiplied by 4. Okay, so this, in a way, you can make use of your multiples, your knowledge of multiples, to find out the value over here first. So when you multiply this by 4, and it is consistent for everyone, if you try to list out 5 and 6, row 5 and row 6, you will see that this rule works. Okay, so 12 times 4 is just going to give you 48 over here. So your answer over here for x would be 48. Okay, so now the next question is this: what should y be? The even part is the easy one. Okay, the even part is the easy version. So now when I go down to row 40, this is where it gets a bit tricky already. Because you have to keep in mind one thing. When it is even, you can multiply this by 4 directly. However, when it is odd, let me use a blue color. When it is odd, you will see that this relation doesn't hold anymore. It doesn't work. It doesn't work when it is odd. When it is odd, the multiple of 4 corresponds to this last column on the right. Okay, it corresponds to this instead. So what do we have to do over here? So here we have to make use of heuristics and try to work backwards. Okay, so over here, when this is even, this row number multiplied by 4 would give us 160 over here. So a lot of you said that y is 160. No, this part we design it this way so that you will get tricked. And when you get tricked, you learn you learn without suffering damage in your exam. So once you have times 4 over here, remember how we described how this pattern grows. It grows from here down 1 row and it goes to the left. So similarly, if we are to work backwards here, this will become 159, 158, and this should be 157. So y should be 157. Okay. Okay, let me address some problems over here. Let me address some questions over here first before I show you the other way of doing. Yeah. Okay, let me summarize the whole thing again. You see that the way this works is that when it is an odd row, it goes from left to right. When it is an even row, it goes from right to left. So over here, the way it changes it isn't absolute that you have to take 2 times 4 to give you a number here. It doesn't work that way. Okay? This pattern number, when multiplied by 4, when this pattern number is even and it's multiplied by 4, it will produce you this number here. Okay, so here this is only row 40. This is an even number. When you multiply it by 4, you get 160. Okay, but this is the end of the pattern because your numbers grow like this. So in order to find this y over here, you have to work backwards. In order to obtain that y. Now, secondly, okay, the second way that this can be done is by grouping. Okay, how do you do this by grouping? So this is a bit abstract, but try to bear with me first. In order to get rid of your odd and even numbers, okay, please listen to this because I'll be using this idea to solve the next problem as well. In order to get rid of irregularities, you want to try to group them together like this first. So the way it works is that in 2 rows, you have 8 numbers. Okay, to solve for x itself, you want to take 12 divided by 2 to give you 6. You have 6 groups over here. So when you have 6 groups over here, and you see that x is the last number, this will be a bit difficult because there is nothing to indicate the columns. So this should simply be 6 times 8, because this will give you the last number. So this will give you x. Then after that, to find out y, you have to take 40 divided by 2 first to give you 20. So you have 20 complete groups. Okay, 20 complete groups would mean that this will be 160. So you can take 20 times 8, then you minus 3 to move back by 3 steps to obtain your y. Okay, this can also be done. If you don't understand this, don't worry, just fall back on this reasoning first. Okay, this is not ratio, this is more on patterns, looking out for patterns. Okay? No, this problem cannot be solved by branching. Okay? It's not branching. Branching is used more often used for remainder types of questions rather than patterns. That's why we always emphasize, right? Patterns, certain heuristics are needed. You can't just have a one-size-fits-all to solve everything. I don't think that's how it works in primary mathematics. Okay? Okay, so let's move on. Okay, I got one question here. What if y appears on row 41? So if it appears on row 41, then you can just do a 41 times 4 because that corresponds with the relation there. Okay, thank you for the question, Zhenhui. Yes. Okay. Yeah. Okay, so let's go on to number 4 first. Okay. So the pattern shown below is made up of rectangles, gray circles, and white circles. So you can see that we tabulated the information here. The table below shows the rectangles, gray circles, and white circles of each figure. Complete the table by indicating the number of gray circles needed for figure 40. Okay, please cancel out this each first. It's not supposed to be there. Okay, so you see the way it changes, right? The number of rectangles corresponds exactly to the figure number. Okay, so that is pretty simple. Now here comes the hard part. The number of gray circles and the number of white circles over here is 3 and 3. Then later on it becomes 5 and 4. Later on it becomes 6 and 6. Then you see that it's very weird. Later it becomes 8 and 7. 9 and 9. If you spot do you spot something here? Every time when your figure number is odd, the number of gray and white are the same. Fn stands for figure number. Okay? Then the next thing over here, okay, Sebastian, you can try to put it to landscape mode and swipe off the comments for the time being. Then that will help you to zoom in, because I need to keep all the information inside here. Okay, so the next one is when it is even. Your gray, okay, let me try to write this somewhere. Your gray, okay, gray is 1 more than white when the figure number is even. Okay? But over here, there is one more little trick that you have to be able to see. Sometimes, in order to get rid of all these irregularities, you have to group them up together. So what we will do is, we will write down the total. Okay? So this column is for total, the one that I'm adding on over here. If you look at the total over here, you will see that 3 and 3 gives you 6. 5 and 4 gives you 9. 6 and 6 gives you 12. 8 and 7 gives you 15. 9 and 9 gives you 18, and so on. And within that total itself, it is always a plus 3. Okay. Okay, so now when your figure number is even, this happens. You want to find out when this is figure 40, what this should be. Okay, so when this goes down to figure 40, you can see that here this is 6 plus 3 plus 3 plus 3. So if we continue with that reasoning that we discussed in example 1, this has to be 6 plus 39 times 3. The total over here. Okay, from the total, you see that 6 plus 39 times 3 will give you 123. Okay, when this is figure 40, this total here is 123. Then the number of gray circles that you need. So remember, we said that the figure number here is even. When this is even, okay, even means as long as it's divisible by 2. Or your ones place is a 0, 2, 4, 6, or 8. Okay, when this is even, then we look at this blue rule over here. Gray is 1 more than white. So if we use a comparison model for this, a bit overkill, I know, but I think it illustrates the point clearly. So we take 1, 2, 3 minus 1, divide this by 2. 1, 2, 3 minus 1 divided by 2 will give you 61. Then your number of gray would have to be 61 plus 2. Yeah, 61 plus 1 to give you 62. Then this would settle part A. Right? No, it doesn't work that way. It's not 41 plus 42. Wait, Yeah, please don't go and please don't anyhow spam and stop scolding each other. Okay, before I ban you, you better stop. Okay. Okay, right. So this will be $62. This will be 63. Y divided by 2. This is a comparison model. The gray is one more than your white. So you obviously you have to take away the 1 divided by 2 to get 61, and then you plus 1. The faster way is you just take 1, 2, 3 plus 1 divided by 2, but not a lot of people can see that. So that's why I'm going through this by a more fundamental approach. Okay, so once you're able to see this already, next one. Here. Okay, block already. Yeah, I can't stand people who are going to disrupt the lesson. Okay, so find the number of white circles in figure 37. In figure 37, this is an odd number. So, if this is an odd number, the number of gray and white squared must be the same. So using that relation, if this were to be 37, the total would have to be 6 plus 36 copies of 3, because the number of 3's that you add on is 1 less than the figure number. So this will give you 114. Okay, when this is 114, okay, when this is 114, because the number of gray and white are the same, we can simply take 114 and divide this by 2. Then this would give us 57. So this will settle part B. Okay, your answer here, for A this will be 62, for B this would be 57. Okay, so let me just describe what I just did earlier. Just now I just banned one root student. Probably he's still young and all that, but I can't really tolerate a learning environment where one has to put the other down to feel superior. Okay, I will not tolerate this kind of nonsense. I mean, for those of you who are spamming out of fun, innocent fun, no evil, that one, I'm totally okay with that, because it's an excitement, I think, for you. But with an intent to put others down, I can't tolerate that. Okay? Is there a formula for every question? Not necessarily. Not necessarily. There are some questions where they involve figures okay, have you ever seen a pattern like this? Like they give you these 6 boxes here, then they give you 2, 5, 6. Then they give you this 10, 30. Then they ask you to find this one. It doesn't follow a specific formula. Rather, it follows a rule whereby this number is always formed by the product of the two bottom numbers. So this is an example where it doesn't really follow a formula, but rather it follows a rule. Okay? How many ways are there to do pattern questions? Depending on how you want to reason it out, but this is quite open. If you want to do this by looking at the gray circles alone, it also can be done. Okay, why plus 6? Because your total here, the first term is the fixed term, 6. So you add 3 over here, you get 9. You add another 3, you get 12. So you see that over here, the number of 3's that you add is 1 less than your figure number. Okay, how to ace maths? You have to really understand the ideas. Okay, there's no other way around it. Because the PSLE questions, the way they said it is quite, some of them is really quite new and surprising. Revise and study helps because there are certain questions that are based on familiarity, such as finding the area of triangles and all that. Okay? Don't worry, Unicorn, he can't read what you're saying, because I've already blocked him. Okay? So, thank you all for staying with me until here. This is the first time I blocked someone, to be honest with you. Okay, right. So over here, we have our June holiday workshops open for registration. Okay, and for patterns itself, we are holding this workshop on the 13th of June for all 3 levels from P4 to P6. Okay, if you need to, you can come to this website to register. I think it's quite easy to remember, mathsheuristics.com/register. Okay, let me just type it in real quick. Okay. Is this the same method as the previous question, the grouping method? Yes, in the sense that you have to group up the odd and even numbers together, and no, the gray and the white together to find out their total. Then once you got that total already, you can use that to predict more consistently what figure number it will be. Or rather, you can use that relation to find out how many gray and how many white you have. Okay? Yeah, I understand. Today there's like a lot more people than usual. No, this one is not free. This one is a paid workshop. Can parents go with child? No, this one is for the child only. It will be very awkward if another adult is inside there. It would affect the whole equilibrium. Okay, you're welcome, Susan. Yeah, the lesson is over. No, this one is strictly for children only. Okay, because there is a lot to cover, we have taken out. We are going to cover these patterns as a standalone. Okay, and on top of that, we also have the heuristics approach to problem solving, where we cover heuristics such as guess and check, making supposition, working working backwards. And systematic listing. Okay. Okay, you're welcome. No, unicorn, I won't leave you lah. Okay, you're welcome, Valerie, Jessica, Reka, Janice. Okay, so Rose is asking, can my P4 attend the P5 session as he is quite competent in math? The answer is yes. We are okay with P4 students attending P5 or even P6 courses. But one thing we have to be upfront with you is that we will cover it at the normal P5 pace. And we will not compromise the pace because your child is in P4. This part I have to put upfront first. Okay, how much is the June holiday workshop? You can come here to take a look at more information. Okay. Yeah, I banned that student. Yeah, I banned him. The reason is, first of all, I mean, everyone has different learning abilities. Even for myself, I'm not like the exceptional genius kind, you know. So I understand how it feels. And I also have friends who are exceptional geniuses, but they are not doing too well in life either. Then, secondly, it's just not very nice, I think. Then, if it's going to affect other students, I might as well just ban one to save the rest. It won't be good for our business, but to be honest, I'd rather protect all our listeners. Why he can still speak? Is he still speaking? He's not appearing already. How hard is a PSLE question 5 marks? Okay, I don't know why you are appearing here. Okay, I gotta look into how to ban people. But anyway, 2015 and 2016 patterns questions came out. You go and look it up. It came out a 5 mark question on question 18 for both of them. Okay. Okay, you're welcome, Julia. Okay, so if you want more additional practice questions, okay, not sure if you can see this. You want to go to facebook.com/groups/maths heuristics. Okay, then under the text, search for patterns. Yeah, again, I'll look into ban people. Not too sure why. I have a 10OP page on Facebook, yeah. We also have that. But that page doesn't have all these questions. Go kopitiam. No, I don't drink my coffee with sugar or anything on. Mine is kopi or kosong kao. Okay. Bye bye, Janet. Well, I'm not stressed. To be honest, lesson time is like the most relaxing time for me. The preparation one is the part that I need to worry about. But delivery wise, everything for me is quite second nature already. Okay? Bye bye. Okay. So if there's no further questions, this is Kevin from Heuristics signing off. Thank you all for having me. See you all soon. Bye bye.